talk about even and odd functions. First off, you should realize that most functions are neither even nor are they odd. But one of the reasons it's worthwhile to learn about even and odd functions is because the trigonometric functions are even or odd. So it's very useful to get a good grasp of this so you can manipulate the trigonometric functions easily. So I like to start with even functions. In even functions, my favorite even function is this one right here, the function x squared. And graphically, the thing to notice about an even function is that they reflect perfectly across the y-axis. So that's my hand-drawn characterization of the graph of x squared. Let's see what it looks like on the calculator. A little bit slow. Okay, so there's the graph of x squared on the calculator. Now you can see right now that has changed to red, from blue to red. But actually what I did was I made the function different. I changed the function to x minus 0.01 squared. So we shifted it to the right by 0.01, and but it looks exactly the same. So sometimes you cannot rely on your calculator. And let's put the other one up now. Let's see if we can see them both together. We might not be able to because they're both so close. Yeah, see, they're very close. But so sometimes you won't be able to tell one from another for sure. So we have to be able to look at a function algebraically. We can't just look at the graph and say, oh yes, that's even or odd. The graph is going to indicate to us whether it might be even or odd, but you still need to know how to check algebraically. So I'm going to come back to my function of x squared here, and I'm going to say an even function is where f of x is equal to f of negative x. Let's try and see what that looks like really on the graph of x squared. So the graph of x squared, we know we have the point 0, 0. We know we have the point 1, 1. We know we have the point 2, 4. And we also know we have the point negative 1, 1. And the point negative 2, 4. So let's take a look at this point right here. In this case here, x is equal to 2, and y is equal to 4. Or we could say x is equal to 2, and we're evaluating our function at x equals 2, and that equals 4. So it's a little bit different way of looking at it. It kind of brings us back to the issue of why is f of x equal to y, which I think is an important thing for you to think about and really deeply understand. But I'm going to look at it this way. X is equal to 2, f of 2 is equal to 4. Well, if a function is even, it says that f of negative x is equal to f of x. Well, let's look at it in our example. F of negative 2, which was our 2 is our x right here. F of negative 2, well, we go back to our graph and we know an x squared. That is in fact equal to 4, which is the same thing as f of x. So that point confirms that this function is probably even. You can't just do it on a point-by-point basis. You need to know how to do it algebraically. So if I was to go f of x is equal to f of negative x, and my function f of x is equal to x squared, well, what I want to know then, what is f of negative x? Well, if I'm evaluating this function here for negative x, then I'm going to go, well, that is equal to negative x in parentheses squared. I'm evaluating it for negative x, and when you square negative x, you indeed get x squared, and we can see that f of negative x and f of x, they are the same. So the function x squared is even. What about an odd function? What is an odd function? So an odd function, my second favorite function, is the function x cubed. That is an odd function. So let's try and figure out why. An odd function says that f of negative x is equal to negative f of x. So let's put some points on this function. I know I have the point 0, 0. I know I have the point 1, 1. And I know I have the point, let's put it way up here, 2, 8. And I know that it has the point negative 1, negative 1. And I know that it has the point negative 2, negative 8. Those are all points on the graph of x cubed. So let's take a look at the point x, where x equals 2. So if I evaluate my function, f of x, f of 2 is equal to 8. Now, that is f of x. Let's take a look. What would an f of negative x be? So f of negative 2, that's f of negative x, well, we can see that that is equal to negative 8. Right, that's right down here. F of negative 2 is equal to negative 8. What about negative f of x? Well, here was our f of x right there. And our f of x, which was f of 2, was equal to 8. Well, negative f of 2, I put a negative sign in from that, is equal to negative 8. So I can see that negative f of x and f of negative x, let's put that right here, f of negative x, they are the same. You can kind of see it graphically too. Here is f of x. If I take that and I make it negative, I'm moving it down here. And that y value, that f of negative f of x, is the same y value as my f of negative x. This takes a little bit of thinking about. But when you have this situation, then every point in quadrant 1 is reflected over here in quadrant 3. Or every point in the function that is in quadrant 2 is going to be reflected in quadrant 4. If I want to show it algebraically for my function f of x equals x cubed, then what I do is I always start with the even first. I say f of negative x is equal to, well, that would be equal to negative x cubed. Then if I cube negative x, I can get rid of these parentheses and I get negative x cubed. And I can see that negative x cubed and x cubed are not the same. So this function is not even. Now let's take a look. I figured out what f of negative x is. F of negative x is negative x cubed. But now let's take a look at negative f of x. Well, what I do is I write down f of x, and then I just put it in parentheses, and I stick a negative sign in front of it. If I stick a negative sign in front of x cubed, I get negative x cubed. And I can see that negative x cubed, that is negative f of x, is the same as negative x cubed, which is f of negative x. So my f of negative x is equal to my negative f of x. So this function is, in fact, odd.